Blade 2 promises longer range and crazy durability. But what's changed inside the cell? And does that actually mean faster charging and longer life? Let's cut through the PR. You've heard the headlines. BYD's Blade 2 gives more range, faster charging, and thousands of cycles. Today we'll unpack what's really different about the chemistry, why that matters for charging cycles and battery life, and where the hidden energy thieves, parasitic loads like heater and infotainment still steal your kilowatt during fast sessions. I'll give you numbers you can trust, explain the molecular idea behind LMFP, and show practical charging habits that protect the pack. Hello everyone, I'm Shayan, an engineer specialized in electric vehicle development. BYD's original blade battery put LFP, or lithium iron phosphate cells, into a thin blade form factor and packed them tightly into the car. That design was all about safety, thermal stability, and long life. BYD quoted huge cycle life and pack level claims and rolled the blade widely through its lineup. The one trade-off was slower energy density compared to nickel-based cathodes, so range was a key target for improvement. BYD's marketing and vendor pages emphasized the design's space efficiency and life cycle benefits. So what Blade 2 changes? The big picture chemistry shift. Multiple industry reports and leaks point to Blade 2 moving from classic LFP toward an LMFP type chemistry, lithium manganese iron phosphate, or at least heavy optimization of LFP with manganese addition and cell engineering. LMFP raises the cell's working voltage and in energy density compared with plain LFP, which is how BYD claims big range gains without switching out to nickel cobalt chemistries. Trade press and market analysts are reporting energy density jumps toward the 180 to 190 watt-hour per kilogram ballpark for the next generation blade variants. Those numbers are widely circulated in coverage of the Gen 2 blade reports. At the molecular level, this means two things in plain language. The cathode material is tweaked so each lithium ion moves in a slightly higher voltage environment. That's the manganese or LMFP idea, which lets more stored energy per kilogram. Cell microstructure improvements, coatings, conductive additives, and better particle engineering reduce internal resistance and improve ion flow, which helps to both energy density and charge acceptance. Those sound technical, but the upshot is simple. Higher pack voltage and lower resistance means more range and better high-rate charging potential, if thermal management and pack design keep up. Market write-ups and battery specialists point to LMFP as cell-to-pack optimization as the core driver for Gen 2 improvements. Charging cycles and promised lifespan, the headline numbers. BYD and multiple industry summaries claim blade-derived packs are extremely durable. Public-facing numbers talk about 3,000 cycles or lifetime on the order of 1.2 million kilometers in some coverage. That's in line with other LFP or LMFP claims that prioritize calendar and cycle robustness. On a practical level, 3,000 cycles at a typical daily miles is on the order of several 100,000 to over 1,000,000 kilometers of useful life depending on how the vehicle is charged and used. Those life cycle claims are repeated across vendor and press pages. Two important caveats. Cycle count alone doesn't tell the whole story. Depth of discharge, temperature exposure, and charge power profile all change how fast capacity fades. Real-world data sets show average degradation rates around 1 to 2% per year for many EVs, but high heat and frequent high-power charging can accelerate that. A chemistry that tolerates many cycles in a lab condition can still be stressed by real-life parasitic loads and thermal events if pack cooling or BMS behavior forces repeated high power or high temperature cycles. Putting the chemistry and pack design together, Blade 2 claims to improve charging cycles because higher usable voltage and lower internal resistance let the cell accept charge faster with less internal heat generation. That reduces the thermal stress per fast charge episode. Industry reporting suggests a Gen 2 blade support higher C-rate charging than an older LFP pack, translating into faster top-ups in ideal conditions. Better thermal tolerance and pack architecture spreads heat more evenly, lowering hotspots and cause uneven aging. BYD and analysts emphasize pack-level thermal distribution as a practical advantage. Cell chemistry tweaks like LMFP style reduce some of the chemical pathway that cause capacity fade at high voltages. So overall, calendar and cyclic degradation rates improve in lab conditions. Market pieces on LMFP highlight better energy density and robustness versus plain LF. Even if they still accept charge better, three practical limits can still throttle real-world charging cycles. Thermal management systems like battery heaters, coolant pumps, and HVAC that can draw kilowatts during cold and hot conditions, which sometimes is enough to reduce net charging power or force slower sessions. Vehicle software and BMS behavior. The car may reduce charge current to protect modules if it detects temperature gradients, aging cells, or connector issues. Software update over the air can improve charge profiles, but inconsistencies across models and firmware version mean some cars won't exploit the full chemistry benefits until the software is tuned. Industry coverage repeatedly note firmware and pack level management matter as much as raw chemistry. In short, better chemistry reduces one big cause of wear, but the rest of the system must be coordinated. Thermal design, software, and parasitic management determine Blade 2 whether Blade 2's potential translates into a longer real-world cycle life. Manufacturers can claim chemistry wins, but owners live with charging stops, slow mid-sessions, power, and long-term degradation that results from the whole system interaction. If the pack can do 3,000 cycles on paper, but the car's thermal system and parasitic loads force repeated high-temperature episodes, real-life useful cycles will be fewer. The challenge is aligning chemistry, pack design, cooling, and user behavior. What the numbers mean for daily life. Blade 2's reported energy density gains mean a car could translate that to 20 to 30% more range or the same range with a smaller pack and lower weight. Both improve overall efficiency and reduce calendar stress. But verify real-world EPA or WLTP numbers for your model. Press claims are optimistic until validated by official testing. If Blade 2 supports higher C rates, a well-cooled pack could accept faster DC charging, but expect the highest sustained power only when the battery is in its optimal temperature window. And at mid-state of charge, NRL and lab work show preconditioning and thermal prep can raise initial peak power by 30 to 50% in practice. Even with chemistry improvements, repeated daily extreme fast charging will still accelerate aging. Recurrence fleet level data and battery research show frequent high power cycling increases degradation relative to gentler patterns. So Blade 2 may broaden the margin, but it doesn't remove the rule. Heat plus high voltage plus extremes means faster degradation. So how to charge or protect the Blade 2? Use level 2 charging like 7 kW charging for daily top-ups and keep state of charge in the 80 to 20% window for routine use. That minimizes stress on the pack and leverages Blade 2's cycle robustness. When you need fast charging, precondition the battery en route and avoid arriving at 100% or at extreme temperatures. Preconditioning is proven to increase effective charging power and reduce thermal stress. Minimize parasitic loads during a DC stop. Turn climates off or reduce HVAC demand, unplug accessories, and give the pack time to settle between very high power sessions. Blade 2 is exciting because the chemistry move toward LMFP style cathodes and cell engineering can materially improve energy density and cycle life. But the real win comes when chemistry, pack engineering, cooling, and software are all optimized together. If BYD nails that integration, owners get faster practical charging and packs that actually hit the advertised 3,000 plus cycles in the field. If not, the chemistry's potential will be undercut by thermal stress and parasitic drains. Blade 2's chemistry, 2x plus cell-to-pack optimization point to meaningful real-world benefits. More range, better charge acceptance, and strong cycle life claims. But don't treat chemistry as a magic bullet. Thermal management, BMS software, and how you charge matter just as much. Use level 2 for daily miles, precondition before DC sessions, and cut parasitic loads when you fast charge.